Yeah. So, we have done Blake-Kuznets-Barkey-Plummer equation, right? And there we have seen that whenever we are using this and whenever we are coming to the final form of the equation known as Ergun's equation, this Ergun's equation is very useful when you are applying it for packed bed, right? So now, and I also said, and I am telling repeatedly, that if you can solve problems, then you can think that yes, you have understood the problem or you have understood the theory, whatever has been taught, right? So now let us go and find out a solution of such problem, say one typical problem as it is given here, right? For example, if we say air at 303 Kelvin is flowing through a packed bed of spheres having a diameter of 12 millimeter. The void fraction of the bed is 0.4 and the bed has a diameter of 0.6 meter and a height of 2.5 meter. The air enters the bed at 1.2 atmosphere at the rate of 0.4 kg per second. Calculate the pressure drop of air in the packed bed. Given molecular weight of air to be 28.97 kg per kg mole and viscosity to be 2 into 10 to the power minus 5 Pascal second. So let us solve it, but before solving let us read once more. Air at 303 Kelvin is flowing through a packed bed of spheres having a diameter of 12 millimeter. The void fraction of the bed is 0.4 and the bed has a diameter of 0.6 meter and a height of 2.5 meter. The air enters the bed at 1.2 atmosphere at the rate of 0.4 kg per second. Calculate the pressure drop of air in the packed bed given molecular weight of air is 28.97 kg per kg mole and viscosity of air to be 2 10 to the minus 5 Pascal second, right? Now let us solve this problem. So if we solve this problem, what is given? We have a packed bed, right? So bed is like this and there some spherical materials like these are there. Right, and air is passing through this, right. So we have been given the temperature T is equals to 303 Kelvin, right. packed bed of spheres. So dP is equals to 12 millimeter is equal to 12 into 10 to the power minus 3 meter. Then we have been given that the void fraction epsilon is 0.4. Bed has a diameter of 0.6 meter. So this diameter of the bed D is equals to 0.6 meter. Height of the bed, that is this height, H, is say given here as 2.5 meter, right, and bed, it enters a bed at 1.2 atmosphere. So pressure at the bed inlet is equals to 1.2 atmosphere, right, and the flow rate is given in this way, that it is the G prime, that is mass velocity, is 0.4 kg per second, right, or we can say not mass velocity, we can say this to be the mass flow rate, m dot, to be 0.4 kg per second. Other things which are given are molecular weight of air, m air, to be 28.97 kg per kg mole, right, and viscosity mu is equal to 2 into 10 to the power minus 5 Pascal second, right. Now, if we remember that Ergun's equation, which we said that was delta P is equal to not delta P, it was delta P rho by G prime square phi s dP over delta L epsilon cube over 1 minus epsilon. This was equals to 150 over NRE plus 1.75, right. So first let us then find out the sectional area through which it is flowing. So cross sectional area of the bed, this we can write to be pi by 4 d square is equals to pi by 4 into 0.6 square, so much meter square, right. Therefore, we can write that G prime, that is mass velocity, was 0.4 was kg per second, right. So kg per second divided by the area into 1 by area or CS, cross sectional area, if we write. So this is equal, this is in terms of meter square, right? So that becomes equals to 0.4 divided by pi by 4 0.6 square, right? So much kg per meter square per second, right? So we can say that this is based on the empty cross sectional area, right? So how much it comes then? 0.4 by pi by 4 by 0.6 square. So let us look into this. So it was 0.4 divided by pi by 4 pi by 4 is equal to this, right, divided by 0.6 square is equal to 1.414 is equal to 1.414 kg per meter square second, right? So g prime square we got to be so much, right? Then we have to find out what is the calculate delta P, right? So we have to find out delta P. So now let us assume delta P to be, say, as small as possible, say 0.05 10 to the power 5 Pascal, right? 0.05 10 to the power 5 Pascal. We have already been given P1 equal to, we have been given 1.2 atmosphere. So this is equals to 1.2 into 1.01325 into 10 to the power 5 is equals to how much? 1.2 into 1.01325 is equals to 1.2159 into 10 to the power 5 Pascal. 1.2159 into 10 to the power 5 Pascal, right? So this we have seen. So we can say that if P1 is so much, then P2 is equals to 1.2159 10 to the power 5 Pascal plus delta P. Oh, this P1 P2 will be the minus, so P1 minus P2 is equals to delta P. So P1 or P2 is equals to P1 minus delta P. So minus 0.05 10 to the power 5 Pascal is equals to, this becomes equal to 1.2159 minus 0.05 is equal to 1.1659. 1.1659 10 to the power 5 Pascal. So that is our P2, right? So we got P1 and P2. So then P average is equals to this 1.1619 plus 1.2159, 1.2159 is equals to by 2 is equal to 1.1909 10 to the power 5 Pascal, right? So we got P average. So if we get P average, then we can also say the rho average is equals to P average, right? P average into M by R T is equals to 1.1909 10 to the power 5 Pascal. M is molecular weight, that is 28 point, it was given 28.97, right? R is 8314 into T is 303, right? So then rho average then comes to be equal to 1.1 this into 10 x to the power 5 is equals to this much into 28.97 is equal to this divided by 8314 is equals to this divided by 303 is equal to 1.3695, right? It is 1.3695 kg per meter cube, right? So now we have G average, G prime, we have rho average, right? And now we can say that 1.3695, okay. So we can say now NRE, this is equal to dG, right? D into G, that is okay, D particle G prime by mu into 1 minus epsilon, right? So D particle was 12 millimeter, 12 into 10 to the minus 3 meter, right? Into this G prime is 1.3695, right? And mu given was 2 into 10 to the power minus 5 into epsilon given was 1 minus 0.4, right? This becomes equal to 12 into 10 x to the power 3 plus minus equals to so much into 1.3695, no, G prime was 1.414, sorry, 1.3695 is row average, right? 1.3695 is row average, right? So we can say that it was 1.414, 1.414, right, is equals to this divided by 2 is equal to this divided by 10 to the power minus 5, 10 x to the power y 5 plus minus this, right, divided by 1 minus 0.4 is 0.6 equals to 1414, 1414, right. So NRE has become equal to 1414, right. So now we use that Ergun's equation which we had shown earlier, that was delta P rho by G prime square, delta P rho by G prime square, then to phi s dP by delta L, right. So we have taken a sphere, right. So phi s is 1. So delta P by phi s delta P by delta L, okay. This is this another epsilon cube by 1 minus epsilon, right. So this 3 term into this is equals to 150 by NRE plus 1.75. So out of this, if we say that delta P is now not known, then we write delta P into rho, already we have found out 1.3695, 1.3695, right, divided by G prime, we have found out 1.414, this square, right, times delta phi s is 1. So dP is given as 0.012, right, dP delta L, that is height, in this case given as 2.5 meter, right. Epsilon given here is 0.4 cube divided by 1 minus 0.4, right. This is equals to 150 by NRE, we have found out 1414 plus 1.75, right. Now let us find out delta P times that 1.13, this value 1.3695, 1.3695 divided by 1.414 square is equal to this, that is 0.6849, okay, 0.6849. So this times 0.012, by 2.5 0.012 divided by 2.5 is equal to 0.0048. Right, into 0.4 cube is this divided by 1 minus 0.4 is 0.6, so this becomes 0.106. 0.106, right? So this is equals to 150 by 1414. 150 divided by 1414 is equal to 0.106. 0.106 plus 1.75, right? Or delta P then becomes equals to, this is equals to 1.75, 1.75 plus 0.106 is equals to 1.856, 1.856, right? So then delta P becomes equals to 1.856 divided by 0.6849 into 0.0048 into 0.106, right? So 1.856 divided by 0.6849, 0.6849 into 0.0048, 0.0048 into 0.106, 0.106. So this becomes equal to 5326, right? Is equals to 5326 Pascal. Now that can be written as equal to 0.05 into is equals to 5 into 326 into 10 to the power 3 Pascal, right? So when we made it this 0.05 into 10 to the power minus 5 Pascal, right? So this means that we have shown that delta P, which we assumed to be 0.05, here also by calculation we have made that to be equal to 0.05, right? So here also we have shown that this delta P has become 5326 Pascal, meaning 0.05 10 to the minus 5 Pascal, 10 to the 5, sorry, not minus, sorry, 10 to the 5 Pascal, 0.05 10 to the 5 Pascal, right? So which was our original assumption. So that means what we have assumed is correct, right? So this way, this is one way how we can use Ergun's equation, right? Do some calculations, some problem solving, then it become more and more conversant with this. Okay, we'll try to solve if we get some more in future, maybe in the following class. Okay, thank you.